This is cubes, part 2. With x cubed plus 27, we first start off by identifying what's being cubed in each position. This is an x that's being cubed, and 27 is a 3 that was cubed. Once we identify that we have a cube problem, you open up your two parentheses. One is a two-term phrase, one is a three-term phrase. Our two-term phrase will always be the two bases with the same sign as in the original problem. Our second term will be the first base squared. X times x is x squared. Our second base squared goes in the last position. 3 times 3 is 9. The middle term will be the two bases multiplied together. X times 3 is 3x. This sign is always a plus, and this sign is the opposite of what was in the original, which will make that one a negative. For number 11, again, start off by identifying what's being cubed in each position. The 8 is a 2 that was cubed. The x cubed is an x that was cubed, and 27 is a 3. Because we've identified that we have two cubes, open up a two-term and a three-term phrase. Let's build. The first parentheses is our two bases with the same sign as in the original problem. Our second parentheses is the trinomial made up of, first, our first base squared. That means 2x times 2x, which is 4x squared. Our second base squared goes in the last position. 3 times 3 is 9. The middle term is made up of the product of the first and second bases. 2x times 3 is 6x. This sign is always plus, never going to be any different. And this one is the opposite of what occurred in the original equation, which will make him a negative. On number 13, it looks different because there's a negative out in front. We can't have that. So this one actually has a greatest common factor that we're going to factor out. When you factor the negative 1 out of the first term, you're left with a to the third. When you factor the negative 1 out of the second term, you're left with a plus 8. Now we have a cube problem. And we'll finish it off at the end by adding the negative 1 out in front. But first, let's identify what's being cubed in each position. This has an a that's being cubed, and this is a 2 that's being cubed. I'll open up my two-term and my three-term phrase. The two-term phrase is the two bases with the same sign as in the original problem. The trinomial part of it is the first base squared. A times a is a squared. The last term is our second base squared. 2 squared is 2 times 2, which is 4. The middle term is the first base times the second base, multiplied together. And this is always a plus. This sign is the opposite of what's happening in the original. Now, number 15. When the numbers, I forgot something on that, didn't I? Don't forget to bring down that negative 1. Now, on number 15, that actually looks like it may have something in common all the way across. I'm going to see if 3 divides into 648. Yes, 3 times 216. I could break it down more, but I don't want to. 1029 divided by 3 would be a 343. Okay, they both have a 3 in common. I just started looking to see what they had in common. They also have an a in common. So on these, you would have to take out the greatest common factor. Now, you're not likely to see something this large on a test, but it is important that we're able to do it. So when I factored the 3a out of the first term, I'm still left with a 216, and the a got factored out also. When I factor the 3a out of the second term, I'm going to be left with a plus 343 a to the third. Now that's the cube problem that we'll factor. That's going to factor into a two-term phrase and a three-term phrase. But first, we'll identify what's being cubed in each position. 216 is a 6 that's being cubed. 343 is a 7 that was cubed, and a cubed is an a. Once we have the bases identified, our two-term phrase will be the first base, second base with the same sign as in the original problem. In the trinomial part of it, we will build. The first base squared goes in the first position. 6 times 6 is 36. The second base squared goes in the last position. 7a times 7a is 49a squared. The middle term is made up of the two bases multiplied together. 6 times 7a is 42a. This is always a plus, and this sign is the opposite of what was happening in the original equation. A couple more. If we have 64x cubed plus 1, the number being cubed in this position is a 4x. The number being cubed in the second term is going to be a 1. Once you identify it's a cube, you're going to open up your two parentheses, a 2-term and a 3-term. Our 2-term phrase is going to be the two bases with the same sign as in the original problem. Our trinomial is built. First base squared. Well, 4x times 4x is 16x squared. Our last term is our second base squared. 1 times 1 is 1. Our middle term is made up of our first base times our second base, 4x. This is always a plus, and this sign is the opposite of what was happening in the original. I think I'm going to do one last one, and then you can finish up the others if you'd like. 343m cubed is a 7 and an m that were being cubed. 64n cubed are a 4 and an n that were being cubed. We're going to open up our two parentheses, a 2-term and a 3-term phrase. Our 2-term phrase is the two bases with the same sign as in the original problem. Our trinomial we're going to build. Our first base squared goes in the first position. That's going to be a 49m squared. Our second base squared goes in the last position. That is a 16n squared. It's really important when you square that you say 7m times 7m is 49m squared. And 4n squared is 4n times 4n, which gives us 16n squared. The middle term is made up by multiplying 7m times 4n, which is 28mn. This sign is always a plus, and this sign is the opposite of what's happening in the original. All right, I'll see you in the next section.